Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Isman Haziq. Today I'm going to present about measurement of precipitation. So my matrix number is 3202037092. So the content that we have is, first one is introduction, number 2 is type of rain gauges, and number 3 is presentation of rainfall data. So first one is introduction. Precipitation is expressed in terms of the vertical depth. Rainfall is measured in mm or cm of water depth. The amount of precipitation is measured using a rain gauge, also called pluviometer, ombrometer, hydrometer, and other. The last one is rainfall catch is affected by the exposure, installation, conditions of the rain gauge. So the type of rain gauges, measurement of precipitation. There is two categories of rain gauges. Number one is non-recording gauges. Number two is recording gauges. For recording gauges, we have three, which is a tipping bucket, float type, and weighing rain gauge. Installation of gauges, there is a procedure, which is number one is flat and open space area located 4 meter from a building or tree with a height of 8 meter, 75 cm from ground surface. So first is non-recording rain gauges. These rain gauges just collect the rainwater but do not record the quantity of rainfall. Example, Simon's gauge, circular collecting of a 12.7 cm diameter of a tree at 30.5 cm height above the ground level. Receiving bottle cannot hold more than 10 cm of rain. Recording gauges give a permanent automatic record of rainfall on the graph paper. It produce a plot of cumulative rainfall versus the time mass curve of rainfall. So I have told you before, recording gauges, we have three: tipping bucket, floating or natural siphon, weighing rain gauge. Okay, we also can measure a rainfall by radar. In an integrated system for measurement of rainfall gauges are used for measuring the total amount as well as intensity of a rainstorm. And microwave radar, wavelength 3 to 10 centimeter, is used for determining the areal extent, location, and movement of rainstorms. Also, the amount of rainfall over large area can be determined using radars with a good degree of accuracy. So the hydrological range of the radar is about 200 km. Heavy rains is 10 cm radar. Light rain and snow is 5 cm radar. Doppler type radar are used for measuring the velocity and distribution of rainfall. So presentation, the last one. This is the last one for this presentation, which is the presentation of rainfall data. So in graph form, we have a bar chart, hydrograph, rainfall hydrograph. The second one is a mass curve, accumulative rainfall versus time. And the last one is double mass curve to check or correct any missing data can be obtained by GPS, which is Jabatan Pengayaran dan Salaran. So for hydrograph, a hydrograph is a graphical or bar chart representation of the distribution of the rainfall intensity over time, and area under a hydrograph is equivalent to total precipitation received in that time period. So the second one is mass curve of rainfall. It is a plot of accumulated precipitation in its time, plotted in chronological order, and records of a fluid type, weighing bucket, other rate, and other rain gauges are of this form. It can be prepared for recording rain gauges also if the approximate start and the end of the storm are known. It gives information on the duration and magnitude of a storm. Intensity at the various time intervals in a storm is equivalent to the slope of a curve. So the last one is a double mesh curve. Is used to check the consistency of hydrologic data by comparing the date for a single station with that of a pattern composed of the data for several other stations in the area. The double mesh curve can be used to adjust inconsistent of a rainfall data. And that's all for me. Assalamualaikum warahmatullahi wabarakatuh.